Okay, how do we find the distance between 2 points in space if we're talking about vectors? Well, it's good to remember with coordinate geometry how we did it first, before we knew about vectors. So let's imagine that there's an axis here in coordinate geometry, like the kind of stuff we used to do before we knew about vectors. And so here, let's say that this is a x coordinate of 4. This is an x coordinate of 10, or I don't know, 8. And this guy is a y coordinate of 2, and this is 6. Well, that's your coordinates, and if you want to know the distance between them, I hope that you remember that what you need to do is Pythagoras, because you want this distance, which is essentially the hypotenuse, and you can do that by creating this little triangle, this is the difference in the x coordinates, this is the difference in your y coordinates, and then you just do, if this is your point A and this is point B, then we can say that x and y for A are 4 and 6, right? And for B, 8 and 2, x, y. And so if I want to know this height of this triangle, I need to subtract the y, so this is delta y, or change in y, and here subtract the x's, this is delta x. So if I want to know the distance between A and B, I need to do the changes in x squared plus the changes in y squared square rooted, right? And to get the change in x, I need to do x2 minus x1. So the usual formula that you see written, that looks a bit long, is just the difference in x's plus the difference in the y's all squared, and take the square root of that. If we do this, we get the distance between A and B. Okay, so that's just a little recap on the coordinate geometry method of finding the distance between 2 points. What about vectors? Go away. Okay, with vectors, we need to remember just quickly that when we subtract two vectors, like say I've got this vector over here that points to this point. This is point B, okay, and this is the origin, O. Here we're talking all about points in space, so everything we're saying applies to position vectors, right? Because there's points in space. So the coordinates of B are going to be vector OB, right? Very often it's written like that on the textbook, OB. And then you have this other point, OA. You have this point A, and the vector that points between there and there is OA. And so if you ask me for the distance between B and A, those two vectors, well, it would make sense to say that the distance between those two, if I have vector OB and vector OA, right? The distance then, if I wanted to find this distance here from B to A, the distance would be to subtract this whole journey, subtract from that, you subtract this guy, and that's going to give you the remaining, so that guy. So if we do this minus this, it would make sense that we would get from B to A, right? With distances, that's what you would do. If this was 100 miles and this was 40 or kilometers, then the distance from B to A is obviously going to be 60, assuming these are all in a straight line. Right, hopefully that makes sense. But this, in vector form, it would be like saying this, that the vector BA equals vector OA minus vector OB. Right, so the vector that points from B to A, the second vector, is always the one that starts here positive, and from that you subtract the first vector. So I hope that makes sense. Now, that's very intuitive when they're like that, but sometimes most of the time the points are not like that on the same line coming from the origin. but the formula still works. If I want to get if I have that vector there and this vector over here, and I want to start asking about the vector that points from one to the other, so I can then find the magnitude of that third vector, and therefore I know the distance between the 2 points, then I've got to subtract them. So if this is A and this is B, then if I subtract, if I do B minus A, if I want to go from A to B, I need to do B minus A. So if I want to go from B to A, sorry, I need a different tool. If I want to go from A to B, I need to subtract OB, I need to do OB minus OA. So this would give me this vector here, which I'm going to call, for obvious reasons, AB. Right? If I want to know what AB is, then I need to do OB, in this case, minus OA. Okay, notice that here the second one was B, so he comes first. OB minus OA, that will give me this guy. It will give me this vector. Once I get that vector, that answer, then I can take the magnitude of the vector, right? And imagine that the answer was 2, 3, and 4 for the answer of that in 3 dimensions. Then if that's the vector that points from A to B, and I'm looking at that distance, the distance from A to B, then I need the magnitude of that guy, and then I've got my answer, the length of that vector. The magnitude of that guy, you do it by Pythagoras. 2 squared plus 3 squared plus 4 squared, all square rooted. That gives you the magnitude of the vector. If you think about it in 2 dimensions, it makes sense that the coordinates of one of the places squared plus the coordinates of the other squared, all square rooted, will give you the hypotenuse and the length of a vector, just a bit similar to the discussion we just had. So it's interesting that when you have 2 vectors, like say this one and that one, when they come out of the same point, like position vectors pointing to 2 distances, so actually to subtract 2 vectors, all you do is you create this vector that points from the head of one to the head of the other, which is different than when you add vectors. Okay, and that's an important thing to mention, that when you add them, you don't do that. You have one vector, and if I want to add another one, I add it to the head of it, right? I add it to the head, and then my resultant is going to be this guy, from the tail of the first guy to the head of the second guy, right? So that's how you add vectors. But when you subtract, you actually go from the head of one to the head of the other, assuming they all leave from here from the same point, and you can always force that to happen. Okay, so then I wanted to do an example from, actually a physical example. Let's do that. And while I get ready for that, I'm just going to post this. Okay, so a question might say, find the vector AB, and hence determine the distance between the 2 points A and B. And they give you that A has coordinates -1, 5, 1, and B has coordinates 4, 5, -1, 4, 5, -1. Okay, and so what we do to find vector AB, remember, is how we do, since B is the second letter, we do OB minus OA. So position OB is this, position OA is that. So we do that, we do OB minus OA is going to be equal to AB, which is what they're asking us to find first. We do that, and then we find the magnitude of AB, and then we're going to have the distance between them. So that's very easy. So let's see, OB minus OA, that's going to look like 4, 5, -1. Now, the question actually has it all in i's and j's and k's, but hopefully you've learned to do it this way because it's a lot faster. Here we go. 4 minus -1 is 5. 5 minus 5 is 0. -1 minus -1 is 0. So the length of this is actually very easy to see already, but if you use the formula, 5 squared plus 0 squared plus 0 squared, all square rooted, it's going to be 5 squared, 25, square rooted, it's going to be back to 5. So the length of a vector which only has one of the dimensions is always just the length of that dimension, right? So we found that the distance between points A and B here is just 5. Okay, the questions can get a little bit more tricky, and I'm going to go into a more difficult one in the next video so that I don't saturate you too much with this one. But they can ask things like, hey, here are 3 points that define a triangle, tell me if it's isosceles or not. Something like that, right? And that's closer to what you would get in an exam. So an isosceles triangle, if you remember, has 2 sides that are the same, and then has one side that is different. So these 2 sides could be the same, and then this distance here would be different. And to show that, you would have to get the 3 points and figure out the distance between all of them and show that 2 of them were the same and 1 of them was different. Then you answer the question. Or you could say prove that it's a equilateral triangle, etc. So they would literally just give you these 3 points on the edges and ask you to show that the properties of some shape that is described by those points to do with their lengths is such and such. And then you would have to be using these ideas of distance between 2 points. Okay, see you in the next video.